everyone. I am Oni. Today, new chapter, chapter 2, probability and probability distribution function of random variable x. Okay, this is going to be a long chapter, I think. Today, sample space and probability. You know probability, but formally, how to define probability. Okay, you see shortly, because probability you have bad experience because it is pretty hard to study when you were in high school level. Okay, anyway, we use word probability frequently in our daily lives. Okay, probability is the likelihood of event of an experiment. So, expressed as a value between 0 and 1 or as a percentage. You know, this kind of thing, in common sense, you know that. We might say something like there is 120% chance probability I will get promoted in this round of evaluations, which is this kind of thing. Wording is exaggerated way of saying it is certain. Okay, 100%. It is certain means 100% probability. It is also important to know probability is defined over sample space. Formally, theoretically. Sample space, what is a sample space? Sample space is the set of all possible outcomes of an experiment. Set of all possible outcomes of an experiment. Okay? This concept is a sample space. This concept of a sample space is similar to that of a population. What was population? Population is the set of all data of interest, right? So very similar, actually same thing. Sample space, population is the same thing. But in statistics, we do not deal with sample space. We deal with population. That's why I'm going to introduce probability shortly. See, let sample space S, the set of all possible outcomes of an experiment. When tossing a coin, sample space H and T. H means head, T means tail. When tossing a coin twice, sample space is going to be a little complicated. HH, HT, TH, TT. There are 4 elements in the sample space. When rolling a die, sample space is 1, 2, 3, 4, 5, 6. Rolling a die twice, the sample space is going to be like this, 1, 1, 1, 2, up to 6, 6, right? For support status of 44 million voters for the President A, okay, we see this example at the population. 44 million instances of like support. There are 44 million here. Support, non-support, non-support, support, dot, 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 support. They are 44 million elements in this population. We do not know who is support, whose status is not support. But anyway, they are 44 million. This is like a population, okay? The sample space for the monthly living expenses of a man in their 20s. Sample space is S. X is monthly living expense greater than 0. This is going to be a sample space. This is also a population of we are in interest. Definition of a probability. Probability P dot Y dot Y I is just denote P dot. Probability is a function defined over sample space as denoted by as P dot. That's why it is a function. Probability is a function. What is a function? S is here to P. P dot. What is P? P has value from 0 between 0 and 1. So any element or subset of S gonna be here has value between this area. For any subset A of a sample space S, PA should be greater than equal to 0, not negative value. PS, total what? Sample space, the value of P should be 1. For any subsets A and B, P of A union B is PA plus PB. If A and B, A intersection B is empty set. Do you know what this empty set? Okay, Venn diagram, A and B, like this. Here A, here B, then A intersection B is empty set. In this case, A and B are mutually exclusive. Okay, all right. Next, shortly introduce probability, definition of probability. Now, a little more complicated thing, joint probability. Once a sample space and the probability for a single experiment are defined, then the sample space and the probability for multiple experiments can also be defined. It is a joint probability. Joint probability refers to the probability of two or more experiments occurring together. Joint probability, two experiments. So P dot dot. Joint probability is defined as a function over sample space as S1 times S2. For two experiments, S1 is the sample space of the first experiment, S2 is the sample space of the second experiment, right? And expressed as P dot dot. And this is a probability, okay? So it must satisfy two conditions for any subset A of S1 and any subset B of S2, P A B greater than or equal to 0. This is a property of probability, right? And the P of a whole sample space, PS equal to 1, 0. Okay? Example, when a coin flipped twice, the sample space S can be represented as S1 HT, S2 HT. So the sample space in this case, okay, HH, HT, TH, TT. For each element of S, the joint probability is P of HH, P of HT, P of TH, P of TT, same. What? 1/4, 1/4. Second example, rolling a dice twice. S1, 1, 2, 3, 4, 5, 6. S2, 1, 2, 3, 4, 5, 6. So in this case, S, okay, 1, 1, 1, 2, 1, 3, 1, 6, 2, 1, 2, 2, up to 6, 1, 6, 2, 6, 6. 36 elements. So probability of each element is 1/36. And probability that sum of two numbers is 5. Where? Where are they? This one, this one, this one, this one. So 4. 4/36. This kind of concept, okay? You just understand this kind of concept, no more than that for statistics. Weight and height of high school seniors. Sample space are defined as S1 is for weight, S2 is for height. Then X greater than 0, Y greater than or equal to 0. So then S gonna be this way. So that is what? 1/4. This area is sample space S. Joint probability of absentees in Department A and Department B. There are two departments, A and B. Good company. Okay? Assume the joint probability of PAB like this. Number of absentees. A, 0, 1, 2. B, Department B, 0, 1, 2, 3. From empirical results, we assume joint probability of A and B. Okay? Then 0, 0, 0.05, 0, 1, 0.05, 0, 2, 0.1, 1, 0, 0.05, something like this. So what the sum of this probability should be equal. And there is no negative values here. Okay? What is blank? Blank means 0, 0. So let's see graph. This is it. department A, department B, 0, 1, 2. Okay, 0, 1, 2, 3. 0, 0, 0.05, right? 0, 1 here, I'm sorry, 0, 1 here, okay, 0.05. And 0, 2, double, 0.1. Here, 0. So this kind of a thing is graph of this joint probability, right? You can see that it is a three-dimensional graph. What is the probability E union F? Oh, this one is probability E plus probability F minus probability E intersection F. I think you studied this kind of a formula, yeah, this kind of a thing in high school level, where A is A greater than equal to 1, F is B greater than equal to 2. A greater than equal to 1 here, right? B greater than equal to 2, right here. So this one is 0.8, right? This one, F, probability of F here, 0.6. And E intersection F is, where is it? This one, 0.5. So the answer is going to be 0.9, something like that. This is for fun. This one is for fun. You don't have to understand that kind of this kind of a thing for studying statistics. Okay, that's it today. Thank you. Bye.